Okay, in this part, we are going to continue the remaining part of Module 6. We have talked about the Ether channel. Just a quick revision before I continue the part in this meeting. We talk about the Ether channel, where the main goal is we need a redundant link between the devices. So the main idea of the Ether channel here is to group multiple physical Ethernet into one single link. So we have multiple physical Ethernet links will be configured as a single virtual interface or a single link. So in this case, it will not be blocked by the spanning tree protocol. So once we configure the Ether channel, the output or the result can be considered as a virtual interface, and this interface is called port channel. Now, keep in your mind, we have mentioned that Ethernet ports should be the same type, same speed, same configuration in order to be grouped together as a single Ether channel. Also, we have discussed two methods or two protocols can be used in order to configure the Ether channel: port aggregation protocol, which stands for, or we can call it BACB, and LACB, link aggregation control protocol. Now I'm going to continue covering the part of Module 6. So we'll talk about the configure, how Ether channel can be configured. Before we talk about the configuration, we need to take in our consideration the following guidelines. First point, the Ether channel support. All Ethernet interfaces must support the Ether channel, with no requirements that the interface be physically contiguous. What does that mean? I can group, for example, Ethernet port 1, 5, 8, 12, 18 into a single Ether channel. So no need to have contiguous ports. Port 1, 2, 3, 4, 5 only. Speed and duplex is very important. As I have mentioned, same type, same speed. So configure all interfaces in an Ether channel to operate at the same speed and in the same duplex with the same VLAN group as well. And this is what we are mentioning in the next point. So the next point, the VLAN should be matched. All interfaces in Ether channel bundle must, or a group, let me say, must be assigned to the same virtual local area network or VLAN, or be configured as a trunk. It should be as a trunk. Finally, the range of VLANs. All Ether channels support the same allowed range of VLANs. As you will see on the configuration example, how we will specify the range of the VLANs as well on all interfaces in a trunking Ether channel. If the allowed range on VLANs is not the same, interfaces do not form the Ether channel in this case, even when they are set to auto mode or desirable mode. If you remember on the previous class, we have talked about the modes of BACB and link aggregation. We have on, auto, desirable mode. So let us talk about the scenario. In this scenario, or this figure shows a configuration that would allow an Ether channel to be formed between S1 and S2. According to the figure, the speed is same, the VLAN is same, duplex also, it's same in both sides. So we can group them and form one Ether channel between the switches, S1 and S2. So we can have a redundant links, physical links, considered as a one logical link for the spanning tree protocol, so it will not be blocked. So if in this scenario, if this setting must be changed, configure them in port channel interface configuration mode. Any configuration that is applied to the port channel interface, I'm talking about here the virtual interface, the output of the Ether channel actually. It will also affect individual interfaces. Because of this, we have mentioned previously that no need to configure each Ethernet port separately. We can just apply or configure the Ether channel, and it will be applied on all Ethernets. They are member of that bundle or that group. So configuration that are applied to an individual interface do not affect the port channel interface, but the opposite is applied, which means any changes of the port channel interface will be reflected or affects every single individual interface. So making configuration changes to an interface that is a part of each Ether channel link may cause interface compatibility issues. So as you see here, the port channel can be configured in an access mode, trunk mode, and this is the most commonly case, or in an router port. And usually for the trunk mode will be the most common case where we need a multiple physical links or a redundant links between the devices, switches or routers, or switch and router, not on the access mode actually. Now, let us talk about the link aggregation control protocol configuration examples as you see here. So what we are going to do, we are going to explain the steps that should be performed to come out with an Ether channel available on S1. So we need to apply or follow three steps. Step 1, specify the interfaces that compose the Ether channel group using interface range and the interface ID as the global configuration mode. Because of this, we say the range should be the same. Here, the range is a keyword allowed you to set several interfaces and configure them all together. According to the example here, we have select fast Ethernet from fast Ethernet 0, interface 1 and 2. As you see, the range is separated by using the hyphen. So here we are going to a group or bundle together, Ethernet, fast Ethernet, sorry, 1 and 2, by using the command interface range. Step 2, create the port channel interface with the channel group identifier, and we can use any identifier here, mode active command on the interface range configuration mode. The identifier will specify the channel group number. So, for example, channel group 1, the mode is active. Channel group 1, mode is on, and so on. So, as we have mentioned, the mode active keyword identify this as an LACB Ether channel configuration. Finally, to change layer 2, setting on the port channel interface, enter port channel interface configuration mode using interface port channel here number, because we are going to change the configuration for all the group or the ports within that Ether channel. So we need to access the channel group we have created, interface port channel 1. Now we need to change the mode to be a trunk, for example, switch port mode trunk. And we need also to configure the allowed VLAN. So switch port trunk allow VLAN 1, 2, and 20 in this case. So once we access the interface by using the interface port channel command, we need to add the identifier of the interface or the group member, as you see here, channel group 1, so interface port channel 1. So according to this example, S1 is configured with LACB Ether channel. The port channel is configured as a trunk interface with allowed VLAN specified 1, 2, and VLAN number 20. Finally, we need to talk about some common cases where we have Ethernet channel not formed correctly, how we can verify and troubleshoot the Ether channel. So as always, when you configure a devices in your network, you must check or verify your configuration. If there is if there are a problem, you will also need to be able to troubleshoot and fix them. So in general, we have a common list of commands can be used to verify an Ether channel configuration. As you see, all of them using a show command, but with different parameters or keywords, let me say. So we can use, for example, show interfaces board channel. This command is used to display the general status of the board channel interface, as we will see in the coming example. We can use show Ether channel summary here. And this command will use to display one line information per board channel, per Ether channel in other way, because we will call it or name it board channels as we have mentioned previously in the previous part. Also, we can use show Ether channel board channel to display information about specific board channel interface. So show Ether channel board channel 1 according to the previous example here in the configuration, board channel 1. And finally, we can use show interfaces Ether channel command to provide information about the role of physical member of interface of the Ether channel in general. So now, what are the common issues with Ether channel configuration in general? All interfaces within an Ether channel must have the same configuration of a speed and the duplex, native and allowed VLAN on a trunks as well, and access VLAN on access ports. So ensure this configuration will significantly reduce the network problem related to Ether channel. Common Ether channel issues now including the following points. Sometimes assigned port in the Ether channel are not a part of the same VLAN. So this is one of the conditions. All of them should be associated with the same VLAN. Or for example, not configured as a trunk port or a trunk mode, sorry. So both with different native VLANs. Both with different VLAN, ports not configured as a trunk, it will create an issue. So in this case, we cannot form or create an Ether channel. Number 2, trunking was configured on the same of the ports that make up the Ether channel, but not all of them. So it's not recommended that you configure the trunking mode on individual port that make up the Ether channel. When configuring the trunk or a trunk on the Ether channel, verify the trunking mode on the Ether channel, not individual port made or make up the Ether channel. Next issue, if the allowed range of VLAN is not the same, the board do not form an Ether channel, even when the protocol BACB is set to auto mode or desirable mode. Finally, the dynamic negotiation option by using BACB or LACB protocol are not compatibly configured on both ends of the Ether channel on switch 1 and switch 2, for example. So let us see a scenario and let us discuss how we can show, or let me say troubleshoot and fix the problem. In this figure, as we have see, we have a switch 1 and S2, two fast Ethernet ports on S1 and S2, 1 and 2, should be grouped together to form an Ether channel. So the interfaces F01 and F02 on switches S1 and S2 are connected with an Ether channel, but the ether channel is not operational. So we need to check what's the problem. We need to fix the problem. So step one, we can view the ether channel summary information. How we can see the summary? We can issue the command show ether channel summary in order to indicate the status of the ether channel. As you see here, we run show or we issue show ether channel summary, and what we have at the end, it's showing that it's down fast Ethernet 01D, which down, and Ethernet 2 is down on S1 as well. So we can go now to the next step. Next step, view board channel configuration. So we can issue or use show run command, and we can filter or eliminate the output by using begin interface board channel output. So the output will show more details. Output indicates that there are incompatibility here of the modes configured on S1 and S2. Now on S1, when we issue the command, as you see, the mode is on, group or channel group 1 mode is on, channel group 1 mode is on in fast Ethernet 01 and 02. While on S2 now here, channel group 1 mode is desirable. And for the interface 02, the mode is desirable. As we have mentioned before, if it's on the on mode, it will never start negotiation, or it will not exchange the backbee packets. So what we need to do, we need to solve this problem. How? By changing the mode of S1 to be compatible with the mode of S2. So step 3, we need to correct any misconfiguration. To correct the issue, the backbee mode on the ether channel is changed to desirable mode, not on mode, and in this case we are talking about S1 or switch 1. Keep in your mind, ether channel and spanning tree protocol must interoperate. So for this, the order in which ether channel related commands are entered is very important. Means we need to do the configuration, then we need to follow the spanning tree protocol. So which is why you see interface port channel 1 removed. So we need to remove the channel and then re-added the channel group command. Why? Simply, if we just update as an opposite, it will be directly blocked by the spanning tree protocol. Why? Because we have error disabled state in this case. So the order is very important. We need to remove the channel group. We need to add a new one with a correct configuration. So if one tries to change the configuration directly without removing the old channel group, spanning tree protocol error will cause the associated ports to go into the blocking mode or error disabled state. So as you see here, we simply remove the previous group by using the command no interface port channel 1. Now we need to specify the range. We need to specify the channel group one more time, 1, and the mode is desirable. And finally, it will be activated, no shutdown, exit the configuration or the interface configuration mode. So interface range now fast Ethernet 1, 2, channel group 1 is created one more time, no shutdown, interface port channel 1, switch port mode, trunk mode. So no interface port channel, then we will one more time create the channel group one more time. Finally, if we issue show ether channel summary port one more time, as you see with the one line interface or output summary, we see that the protocol is port aggregation protocol, BAC-B, fast Ethernet 1 is up, operational correctly, and it's a part of the channel 1, and fast Ethernet 02 also, it's a part of the bundle port channel 1 as well. So both ports operated correctly and Ether channel now formed correctly without any problem. This is the end of Module 6, which is talking about the Ether channel. Thank you so much for listening.